Well, hello and welcome back for Advent of Code Day 20, hopefully part 2. Well, not hopefully, we have already done part 1, but we got stuck on part 2, and hopefully we can maybe improve this and see if we can get an answer. So, I haven't touched anything since I left. So if you haven't seen what I've been doing, I would recommend to watch the previous video. That is, if anyone watches these videos. So what we have is a working solution for part 1, but part 2 basically does, requires you to do the same thing as part 1, but with much bigger numbers and 10 times. So the working solution that we have for part 1 is not very efficient, and for part 2 this becomes terribly inefficient. Like, it will never get done. We did a smoke run on the well, here I have the actual input, but if I copy the sample input, we did a smoke run on that, and it was taking a lot of time to do even the first iteration for 1, and then as these numbers get bigger in size, it's taking way longer, and the actual input has much bigger numbers. So that solution is completely unfeasible for part 2. Like, we would have to do trillions and trillions of iterations, so that doesn't work. But I have been thinking a little bit about this while traveling and so on, and I think I have an idea that might work. I don't know if it will be decent in runtime, but it should at least get rid of most of the unnecessary computations, and maybe get each iteration of part 2 be comparable in time to part 1. So what is the idea? Let's get into a state. Let's see if I run now, what happens. I think I have part 2 commented. Yeah, and I have these prints of each step. So what we saw is that if we insert a number here, let's say in here, the list becomes 8 numbers. So if we put something like 8, for example, and we run this thing, we see that in this step, when 8 got mixed, well, it advanced, it ended in the same position. We are doing, this solution is doing everything into a vector. So it made 8 turns, and it got into the same position, but it shifted everything else to the left. Like 1, 2 was here, but it ended up here, and the 3 that was here ended up here. So conceptually, what happened is that this 8, this is a circular thing. So this 8 ended up changing positions. It went from being between the 2 and the -3 to being between the -3 and the 3, if you consider this thing circular. So it's as if it advanced 1 and got inserted here. And if we put something like 1 less, a 7 here, the 7 in the array is it went 1 position backwards, because it looped around and ended up here, but it's still on the same position if you consider this thing circular, between 2 and -3. And the same thing goes if you go past it, if we say 9, the same reasoning applies. So the 9 ends 1 position more in the array, but it's actually 2 positions more between the 3 and the 0, if you consider this like a circular list. So given that, I think what we can do is, so for part 2, we are basically doing the same computation, but we are multiplying these numbers for with this pretty big number. It's 800 million and something, so it's a pretty big number. It's a prime number. I don't know if being prime makes any difference. It probably does for a more clever solution, but I'm not thinking about using primality for this. Look at that, the dictionary complaining. Yes, there is Euclid, but of course Euclid is a word. Okay. Euclidean, I guess. Where was I? Distractions. So yeah, my idea would be, we saw that when this was a 7, it basically remained in the same position. So I think what we can do is, for any given number that we have to move around, we can get the remainder of that big number and the size of the array -1. So this array is of size 8, and we know when it's like a 7, or I guess let's try also with a multiple of a 7. Let's try with 14 and see if the same happens. So here 14, it was here, and it got moved two times to the left, but it's actually in the same position between -2 and -3, right? Yes, it is. So any multiple of 7 will remain on the same position. And we can consider any number to make it like mod 7, and then the remainder of that's how many we have to actually advance in this circular list, right? I think that's sort of what's the idea that I have. And I think we can even like actually model a linked list, not with a natural linked list, like with nodes in memory and pointers and all of that, but just having like a vector between indices, like, well, that have tuples of previous and next on each element. But let's see if we can get away with not even using that and sort of using what we already have. So what do we already have? Position. What were we doing here? Oh yes, and since this thing is getting mixed, we needed to do this thing. Okay. This linear search is also like, we have so many linear things. It's like inside this loop that iterates over all the array, we have 3, like a linear search and 2 linear mutations. But well, this linear search is on the size of the array. These linear mutations are the huge things that we want to avoid being huge. Right. Why did we need to do this thing though? Yeah, we have the I. We know. Okay, so it's this. I see. You know what? I think that there is something that we can do here. First, improve this thing slightly. I don't really like this parameter called original numbers, and then have this thing like this vector of tuples be called just numbers. We have some repeated information here. I think I would like to let's call this thing something else. We're gonna give a better name to that. But what I'm receiving here is the actual numbers, are the actual numbers. And instead of having like a tuple of index to the actual numbers, I think we can just have the indices here. We can even call these things like IDs, because these original indices represent the indices of the numbers in this original array. So they are sort of like the IDs of the numbers. So let's call it that. The len could be the length of the numbers. Let's make it very clear. And this thing, let's make it a vector of view size directly. And of course, this is not it. So we could, I guess, do this. Not into that, right? This doesn't, we have to collect. Yeah, just collect. Fine. Look at that. Rust can be very beautiful. Okay, so we have these IDs. And this I is an ID, right? Yes, it makes sense. It is an ID. But we do have to find the position in the IDs array. That's still something that we need to do. So let's maybe rename this I and say ID. This is the ID that we are working with, and we want to find isn't there a, I think there is an index. No, but I want to find it, like, does this work? I wonder. I think it's not index what I want. What is position here? Is it the index? No. This is the same as doing get, I think. Not really sure. Like, this documentation is not the best. What I want to do is like a linear search, not binary search, because this is not sorted. So okay, let's just bite the bullets and say, okay, this thing is this. I want to find this, but there surely must be something simpler that doesn't take a predicate but just takes an element, and it's like, where is this? Yeah, let's look for that first. Element index in spec. Well, yeah, it's violet, so yeah, I have already searched for this. Beautiful. Yeah, no, it's it looks like position is what we want. Beautiful. Yep. Okay, that's good to know. ID must be on the list. Okay, and then the number should be just numbers in this. The number corresponds like for this ID. Okay, that is good. Then we are. What are we doing? Oh, we don't need to. That's great. We don't need to do all this thing here. So So I think this should behave the same. Still need the position of 0. So what do we want to find here? I guess numbers do the same thing. Yeah. And then what I want to do, I'm getting the what is this? Not 0 position, right? Is the 0 ID is this thing, the ID of 0. Okay, yes. Right. Does this make sense? I don't know if this is making sense now, because we found this. Oh, because numbers before it was the modify array thingy, so that's not what we want actually. The 0 ID is this. Then we want to find the 0 position, and with that access the IDs, I think. Right? So yeah, now we don't have, let's say, it's probably a better way of doing this. So we are iterating the numbers. Can we iterate instead? Can we have something like iterating the IDs? Here, say, okay, I have an ID. If the number of that ID is 0, right? That's, I think, what we want. Yes. And then we have the position of 0, and then we are, these are the offsets. Let's call this thing offset. 0 position plus offset all mod len. This is the ID of the next number, so we have to index numbers with this mess. This is a number set. Okay, does this still work? Well, not with the inclusion of this 14 here. Let's run with this, and yeah, 3 was the correct answer for the sample. Let's go to the actual input and see if we didn't break anything with this. Oh, we're printing a lot of stuff. Let's comment this. Let's go again. 8721, is this the correct answer? Yes, that was my correct answer. Okay, so we didn't break anything, and this is a bit simpler, I think, or more understandable than what we had before with mutable numbers thingy. Yeah, now we have an array of IDs, and we shuffle this thing. Good. So what are we going to do then? we are going to advance. Here we are reading the number, right? Let's not think about this. I guess since this is a working part 1 solution, I want to add this on top of the changes that I had, just to have a working thing. Okay, and we are going to think about the forwards and backwards cases separately, I think, again. So if we are moving forward, we want to reduce this number to that mod operation that I mentioned. So let's just say mod or num mod mod num, I don't know, is gonna be num mod length -1. This should be fine. The length should be always bigger than 0. You don't like this because they are probably different things. Yes. So what are we going to do with this num mod? We're just going to use it to count how many times we are going to advance. So I guess we can just say as usize here. That's fine. We are going to, I think, just do the same thing that we were doing before, but a num mod times. Does this make sense? I have no idea. Let's pretend it does. Here, we're basically going to do the same, I think. Let's num mod b, but we're going to grab -num. Okay. As usize. I don't know if the precedence of the as operator is lower or greater than the unary minus sign, so let's be safe and do the same thing. Mod it length -1. And here we're going to advance this amount of times. Well, not advance, go the other way. Okay, then we have the same logic. Does this work? Let's run it with actual input and see if we get... We actually do get the correct answer. All right, then let's try part 2 and see what happens. So here we have the decrypted numbers. I'm just going to uncomment this thing. We're gonna do the same mixing, but 10 times and with the decrypted numbers. And let's do just one thing after each of these. Let's just, you know, print a little dot. And then let's just print line. Okay. Just to see something moving. Okay, let's go. Man, I am a bit hopeful about this. Okay, humongous number. Did I run in release mode? Yes, I did. I don't know if some overflows went by. We're gonna see. Let's try this humongous number. Yes. All right, we have part 2 done. That's great. That is awesome. Not the best runtime, 1 second. I would like to improve that, but we got it running. That's great. We can get rid of these prints, and well, we have some mess too. I don't know when I imported this. Yeah, but I think This is actually a pretty small solution also. So that's nice. Okay, let's add these changes. Let's see how could we improve this. Well, I guess I can already make a commit with these changes. We have the actual input. Do we have anything obvious to improve here? I don't know if we do. Maybe the main function. I think this is fine. Yeah, this is fine. Let's commit this. Day 12 solution. Yeah, no need of extra comments, but we are getting not the best runtime here. 1 second for, well, there it took 2 seconds. And if we run in debug mode, I guess it's going to take much longer. But I think the main problem is probably all the array checking, and we are basically, well, we have a linear search here. We also have this linear swapping of things, so it's reads and writes. This can definitely be improved. So let's try out this idea of having like an actual data structure to represent a linked list. How would I do this? Let's see. I don't want to see this notification here. And what is this? Account sign in. Sign in required for what? I already signed in. Okay. Reload required for YAML. Can I ignore these things? Don't like seeing those patches over here. Yeah, reload. Okay. At least that got away. Went away. And this thing. Signing with. Sure. Yes. Open this thing. Okay, are you happy now? Okay. Annoying notifications. Okay, so let's see. So what happens if instead of having these IDs, we have something like, I want to call this like linked list, but this is going to represent, it's more like, well, let's call it links. It's gonna be a vector of usize and usize. Yeah, I don't know if I also need a vector of IDs like I had before. Let's say links contains prev ID, next ID, tuples for each number ID. Okay. And how are we going to construct this thing? Well, I think we are going to say something like numbers, iterate over this, enumerate over this, and map, and then we'll collect. And how's the mapping going to be? We're going to have an index, a number, and actually we won't use the number. No. We won't use the number. So it's gonna be similar to what we had before. We're gonna go from 0 to lang. We're gonna map these. Okay. How are we going to map it? Well, let's write it in the most dummy way, and let's say if I is 0, then the previous will be lang -1, and the next will be 1, right? Something like that. I guess we can say let's priv id be the edge case here is if I is 0, then it's gonna be lang -1, else is gonna be I -1. And yeah, I can do this with a mod, but I don't want to think about underflows or anything. And the next ID here, the edge case, is going to be if I is lang -1, and in that case it's going to be 0, otherwise it's going to be I +1. Then we are going to return priv tuple with priv ID and next ID, and these are the initial links. Okay, then we're gonna do this loop of mix count times, and then what's here, we're going for each ID. We can do the same. This was already extracted. Let's see. I think we shouldn't need this position, right? Because like we needed the position because we were working with an array, and everything that said position were like the indices on that array of IDs, I think. So I think we won't need this. The number is still gonna be the same, that doesn't change. So we know this, we know whether to move forward or backward. We are still going to need this, I think, to this iteration, but we are not going to be swapping. We're just going to be following along the links array, and then we are going to mutate it, I think. Is that correct? Is that correct? Let's try it out. Okay, this is the amount of times we are going to advance, right? And we are also going to need like a mutable variable. Let's ID How do we call this? Swap ID? It's not. So we want to advance, know the position where this will end. The position is basically which number, or after which number we want to put it, I think. Because basically we want to change this thing, links ID, to remove this number from here and to put it somewhere else. Basically change the previous and next of this number. Okay. Yeah, right. How do we do that? How do we do that? Okay, I don't know how to call this variable, so I'm just going to call it ID2. And we're going to start at our current ID. We're going to advance this number of times. And what we're going to do is say ID2 is links of ID2, like the next of this. Right? Yes, and this already takes care of the circular thing and the model and everything, because we have already encoded this on this list. Yes, all of these prev and next IDs, unless I made a bug here, all of this should be valid indices in this array. So that's good. That's good. So now ID2 is the ID of the number. Let's think about this. Like, is the ID of the number on we have to put afterwards or before? Let's see. Well, let's maybe take a look at the examples here. So we have this arrangement. Here the one has moved here. So I guess the ID that we started was ID 0. And then, the next ID was ID 1, which is the ID of number 2. So we have to put the 1 after this thing. Yes, after the 2. That's it. Yes. So move num2 after number with ID equal ID2 after ID2 number, if that makes any sense. So let's say links for the number that I'm switching, so I'm basically taking it out of here, then what is going to be the previous number for this? Well, wait, which things do I have to change? I have to change these, the previous and the next of this, but I also have to link the previous and next, because this is double linked. So how many links do I have to change? Yeah, being double linked, I think I have to change a lot of links. So I have to change man, this is so difficult to think of. So the previous number from this has a next that is pointing to this, but it will no longer point to this. We have to fix that. You have to point to the next of this. Yeah. So let's say links of can we maybe free of next be links ID? Let's save these things and links prev, make it point. We're gonna modify the next of this should be, I don't know if Rust is gonna like this, the next of this, and the same thing for links next. The previous is gonna be the previous of this. So what we have done here is to sort of remove none from its current position, right? And then we're gonna do, have to think of this. After this is gonna be the number that we are iterating, right? So links of links ID2, this is a mess. So no, this is, wait, the previous, do I need to do this? No, I don't need to do so much, I think. We have, actually I think maybe I do have to index like that. So in ID2, like the next of this, well, it's gonna be ID, but we have to also fix what was actually the next. I mean, what was the next before, we have to make it point, the previous has to point to ID. So we're going to have to say something like this, links, this is gonna be ID, so the previous of this, the previous of the next is gonna be ID, and the next of this is gonna be ID. Yes, we have inserted ID where it should be, but now we also have to update links ID, actually. So the previous of this is going to be ID2, and the next is going to be what? It's going to be, I think it is what this was before, but we have already changed it. So we cannot change it. We shouldn't change it. Yeah, we already have pref and next here, and we have already used them. We have already like saved them. So I guess I can maybe update ID before. So the next should be this. Yes. This is so messy. I don't even know how to comment this, but I think this sort of makes sense. Such a mess. Okay. Let's assume that this is correct, that this mess is correct. We actually have this ID too. We can save a little. We don't have to copy out of that in the else branch. We can put this over here, and we're gonna advance this thing. Move forward is just going to do this, and then we're going to do this out of the if. And here we have to make the logic of moving backwards, but it's just going to be a very simple thing. It's going to be this, going to the previous this amount of times. Okay? This is so horrible. But this is relinking a double linked list, so I think that is usually pretty horrible. I updated 3 pointers, or six pointers between air quotes. So I don't know. Maybe that's correct. Yeah, let's roll with that. So then, after all of that mess, what do we have to do? We have to know the 0 ID and move. Oh, this move of 1,000 times is, yeah, we're going to have to do something similar to this. Yeah, and it makes sense to these numbers are okay, I think. I mean, okay for, like, we don't need to do any mod for here, because these numbers are smaller than the input that we have. We don't have to wrap around or anything. So, okay. The 0, what we first gonna need is the 0 ID. And this is numbers position of n, where n is 0. Yes, that is the ID of 0. And then we are going to start from this ID of 0 and advance 1,000 times, then 2,000 times, and then 3,000 times. Then we are going to add those up together, right? Yes, let's just do it in a very sort of inefficient way, but it's fine. What are we going to say here? Map offset. We have to what? I don't even know if this logic has anything to do. So we're gonna start, you know what, this is this thing I call ID2 is like the ID iterator in some way. And this is the final position or something like that. So we're gonna do something like something similar to what we did there. Let's merge ID iter. Let's start at 0 ID, and then let's do for in 0 to offset. We're gonna do this amount of times, increment or move forwards this ID iter. Gonna be links ID iter, right? I think so. And then we're just going to return the number corresponding to this ID iter. And it should be numbers. And here, what you don't like. Oh yes, is this the next of this? Okay. And borrow, mutable borrow. Okay, fine. So yeah, you don't like it. Okay, that is fine. How should we call this thing? We can extract it into a variable. This is the next. I don't know what is a good name for this variable. I'm just going to call it ID2 next. Oops. Next and enter. Not the best name, surely, but it gets the work done. Yeah. Okay. So I'm a bit frightened to run this. I have not much faith on this. Let's run and see what happens. It's running. It is running, and we got a similar looking number for the first one, but a very different looking number for part 2. Okay. It is something though. I don't know. Where did we screw up? If we use the sample file, should be better for debugging. Well, 0 and 0, that's not very helpful. Where did we screw this up? Where? Well, I guess we could how do we print this? How do we debug this thing? Here we are advancing. This is fine. Here we're going back. This is prev and this is next. Good. The prev and next. Does this make sense? We have the original previous and next. So the thing that was previous, the next should be, yeah, the next here. Oh, if we have something like the thing not moving, well, we don't have that here. But I don't know if this is robust to cases where we don't move, like if now num mod is like if id equals id2, we can continue, I think. I don't think doubt that this happens here. Let's print line this. Actually, I think I didn't run the correct solution for the sample. I just ran it with actual input and rolled with it, but I think we never checked if this was the number, like 1 trillion blah blah was the number. But anyway, didn't move. Don't think that this happens with the sample. Oh, it actually did happen? It did happen? What's... how? It printed this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 times. Oh, the zero doesn't move. Yeah. Zero doesn't move. And actually, now we got a different result than when we were not skipping this. So either there is a problem with this thing we are doing here, or we might be yeah, there surely is a problem. Like, this might not work if we are like reconnecting the same thing into the same place. So it makes sense to do this. Didn't move. Okay. We do get a different number, not the correct one, but a different one. How do we print this? Well, the part 1 is already bad, so let's just avoid part 1. Let's comment this and only print. Sorry, let's avoid part 2. Let's just do this. Let's add some printing. Let's add some printing after the mixing of each number. So println, let's say mixed. And well, let's print something here. So it's going to be numbers of this ID, right? And then what do we print? Do we just print the links? I don't know if I'm going to be able to interpret that thing. Maybe we want to convert the links to an actual list of numbers. But let's see what we have. All right, so mixed 1. The ID of 1 is ID 0, right? Let's also print this ID. And actually, we do have the number here, so we don't need to do this. We can even put links in here and be nice with Clippy. So we mixed 1. That is ID 0. Now 1 says that the next one is ID 1 and the previous is, sorry, the previous is ID 1 and the next one is ID 0. That doesn't seem very right. Let's print the initial thing too. initial is a links as debug. Does the initial state make sense? Yes, the previous is 6 and the next is 1, and then we have something like this. This does make sense. Okay. And when we moved the 1 around, what did we change? Well, we have to change the next and previous of 1. So for 1 itself, let's see, the previous is going to be id like 2, which is id 1, and the next is going to be 3, which is id 2. So 1 and 2, that makes sense. Now the previous, then we have number 2, which is the next of 1. This thing should have had its next changed to 1, and the previous of, no, sorry, the so 2 gets its previous and the next changed. Yeah. And 3 gets its previous changed. Yeah. Okay. That's interesting. So what is, actually id2 is, well, the idea of 2, but that is a coincidence. Because we only advanced 1, so this is going to be the next of 1, this is the id of 2. Okay. So we update the next to be id. So yeah, the next of 2 is 0, and the previous of 2 6, which is okay, right? It is 4, which is the id 6. That makes sense. Okay, so 2 checks out. When did we update 2? We updated it here, and we updated it also when we said that the next was the, no, sorry, that's now here we are doing this. When we said that the next, the previous was the previous of the initial. Yeah, here we are updating the id of 2. No, sorry, this is what would be. Okay, and then the 6th, the previous of the 6 is still 5, which is good, and the next is 2. So I think this is correct. I think. I mean, at least first iteration does seem correct to me. You know what? But this is very difficult to read. So I think it's maybe will pay off to convert this to the actual numbers. So how are we going to do that? So how are we going to do this in a sort of reasonable way? So we have the next and previous. We can start from any ID and just follow along, I think. If we say something like let, I don't know, nums be a vector of all zeros, 0 length. Let's start with this. Say let's I be, you're gonna start at whatever, 0. And what are we going to do? Yeah, I guess we can put this. Yeah, we're always going to print this starting from the 0 because we know. What do we know? I don't know what we know. Now we're going to start this starting from the number of ID 0, which is actually the number 1 in this sample. So for in 0 to length, we're going to say nums well, I don't know, j nums j is gonna be what is gonna be numbers at I, right? And then we are going to advance this I to links I next. You don't like this because this is not mutable. Yes, make it mutable. Let's print then not the links but the numbers. I have no idea what I did just there. So we're not printing the original. Maybe we can do the same thing here and don't care about shadowing or anything. Does the original match what we had originally? 1, 2, minus 3, 3, minus 2, 0, 4. Yes. Okay. And now we put the 1 between the minus 3 and the 2. So this sort of makes sense. Then iteration 2 moves between, okay, 1, minus 3, 2, 3, 1, minus 3, 2, 3, minus 2, 0, 4. Okay, this makes sense. Let's go to the final iteration, which also starts from 1 nicely. 1, 2, minus 3, 4. 1, 2, no, this is broke. Okay. So where did it screw up? We're not saying anything from mixing 0, but that should be the same. When should we? 0 does not move. Yeah, okay. Okay, so we have seen this. The minus 3, after minus 3 is 1, 2, 3, minus 2. 1, 2, 3, minus 2. Minus 3, 0, 4. No, 0, minus 3, 4. So here we screwed up when moving backwards. Minus 3 is the first that moves backwards, so there we screwed up. There we screwed up. We're initializing ID2 as ID, and then we are moving backwards the same way we are moving forwards here. So it's not too obvious to me how this could screw up, but let's think then. Before -3, we have the correct thing. 1 minus 3, 2, 3. Yes. -2, 0, 4. Yes. But afterwards, it's screwed up. That is nice to know, at least. So mixed this number, -3, which is ID, well, the ID now I don't care too much. I actually don't know how the links look. So let's try something weird here. Let's try to use some tabs and also print the links like this. Oof, that's ugly. Why is this so ugly? Well, I guess the tab size screwed us over here. Really? Can we maybe fix that? Let's just put this space over here. Yeah, that's better. Let's say links is this shit. Oh, I tried to commit. Awesome. Let's run it again. Noisy thing. Okay. Yeah, fine. So I wanted to print the links because even though we are printing something here which is wrong after the -3, this is like, to generate this thing we are using the links already, so I'm not trusting these outputs. I want to see the actual links. So 3 is ID 2, so it's this. So before 3 said that the previous one was 0 and the next one was 1. So here's 3. No, sorry, -3. The previous is ID 0, which is 1, and the next one is 2, which is ID 1. This is good. Then 1 said that the next is ID 2, that is fine, and 2 said that the previous is ID 2. This is all consistent, this makes sense. This previous state, I think, is correct. Then the -3 has to loop around and get here, which I think, no, it's not correct. It should have, so how does this look? 1, 2, 3, -2 up to here is correct, then 0 where the -3 should be, and then it should be 0 and 4. Did we moved one less than we needed? Is that it? But how and why? Here we're converting this number to its absolute value because it's a negative number, and doing this same mod. So mod 7, this should be well, let's maybe print this. Gonna move num mod times for num. I don't know, like this doesn't make a lot of sense, but let's just do the printing. Gonna move 3 times for -3. Yes, okay. And well, I guess we can also print where it's going to end up. Since the len num is gonna end up after id 2, which is the numbers id 2. This print-based debugging. So -3 is going to end up after id 5, which is 0. This is going to end up after 0. No, it's not going to end up after this. Oh, it should be before this, because we are moving in the other way. Okay. That's maybe not great, because it means that this code that we had is a bit iffy. Beautiful, so beautiful. I wonder if we can change the negative numbers to like wrap them around and make them positive and just go that way. I wonder. We probably can, but for the time being, let's just say that negative numbers just go num mod +1. Horrible, but I think this should fix. If that was the only problem, yes, part 1. Okay, so let's remove these printings. Yeah, let's comment this. And this actually we don't need. We know don't need. Yeah, and let's go back to this and run the sample. So in the sample, do we have this number 1,623,623 1,623 ends up in 306? Yes, it does. Okay, so let's go with the actual inputs. Run. And this was our correct answer. Yes. And this ending in 825, 831, 825. Yes, this is the correct answer. Okay, and it's I thought we were going to improve the runtime, but it's instead of running in 2 seconds, now it's, well, still running in 1 second. So all the following along this this linked list, I think, didn't make much of a difference. What a bummer. Yeah. Didn't move. So yeah, I don't know if this is a better solution then, because it's not really running faster, right? Well, 800 milliseconds. Well, 800 milliseconds. If we stash and run again, 1 second. We can maybe use time. Time. Is this on? No, not this. Target. Time. Target. Release. Advent of code. Blah blah. 20. .2 seconds. And is this more or less consistent? Yes, it is. Okay. Is dash pop cargo build release. It's time the same thing, and well, it is marginally faster. But I think to make it faster, we will have to find some more clever thing to do, and I don't know a more clever thing to do. This thing is very, very like linear, very linear, and I don't know. I don't know. I think we need to do this following up of the links here to move forward, move backwards. Right? Yes, I think so. I guess we could try to optimize this a little bit by checking, like if the number is less than half of length, like if it's a positive number and it is less than half of length, then it's okay. But if it's more than that, we can just move backwards and find it sooner. And the same thing if it's backwards, like if it's a small, if it's a large backwards number, we can move forward and find the position that way, I think. Nah. Okay. So, am I happy with this solution? Not really. Not a lot happier. And in fact, if we compare the changes to what we had before, I think this is, yeah, this is substantially longer. And it's not really, it is faster, but it's not like way faster or anything. And I have no idea if I could like parallelize this some way. I don't think so. There must be some, there probably is some other clever math thing that I'm not seeing. Like some repeated states or something. Like when we are yeah, here we were swapping things around or swapping them the other way. Yeah, I want reconstructing the numbers each time wouldn't be better either, I think. Because here we are doing, although this is a bit nasty, we are doing only 6 writes and just, well, a bunch of reads, but only 6 writes, where previously we were like swapping and swapping and swapping. I mean, maybe it's not a huge difference since this is all like in the processor cache. Actually, it probably isn't, because we are using pretty big numbers for IDs. So I wonder if we could use smaller things here. And would that make things faster? Maybe it will. Okay, let's tentatively, I don't know if that's a word. Let's say that we will add these numbers, and let's try maybe, instead of using usize for, like this is a 64-bit number. So if this is a 64-bit number, this is 8 bytes plus 8 bytes is 16, and we have 5,000 entries here. So that is what's 16 times 4 is 64 plus 16 is 80. Is that 80 kilobytes? Or am I not thinking correctly and it is 8 kilobytes? I think it's 8, right? And 8 kilobytes is not really that much. It can fit on the L1 cache, I think. Yeah, I think it's 8K. Do we have something to bytes? Mem size of, let's see, Rust, I type Ruby, Rust memory size of vec. Yeah, not any object, just a vec. Of a slice. Okay, so this is mem size of val. Yes, and this is a slice of something, so links. Well, just convert it into a slice, I guess. Prints-ln size is this. Don't expect this to be too big. Nope. Cargo run delete 20. What? I think I didn't do what I meant to. Should I do that? Oh no, it wasn't 8K, it was 8,000K. I was one off by 1 order of magnitude. Okay. Ah, yeah, because this wasn't 500, this was 5,000. Okay, so it is 8K. Well, so maybe reducing this would help. Let's try using 16 bits numbers. So this is 32 bits between these two. And what do we have here? Collect, you cannot collect because you have usizes. But you have usizes because len is usize. Well, what if len might be... Oh, we are using length for the mod operation. So let's say len as u16. Well, yes, as u16. Are you happy now? No, these two don't match. I is uSize. Oh, because, okay, here is where you want to be a U16. Yeah, okay. And then we have ID. We are going like this. Also, I think I should do this. So now ID is the correct size, and we can upsize it when we need. uSize. Here as uSize. Okay. Prev next. Well, here as again as uSize. I don't really have high hopes of this improving things much, but let's see. Let's try it out. We could probably have made this some other way, but yeah, it's fine. Okay, beautiful, beautiful. Zero ID. What don't you like about this? uSize? Yes. Here I converted to another size, but I think this should still run, but no. Line 35. Sure, another as uSize. Sure. Now it's 20K. Yes, we reduced the size by 4. Oh, it is actually faster. That did actually make a difference. It seems like now it's, I guess, like usually this kind of reductions don't make a difference, but maybe this made this thing be more processor cache friendly, and it just fits in there. That's nice. That's quite nice, actually. So another thing I wonder, well, this does work now, and it looks a bit better than before. But now that I thought about this thing of maybe transforming backward moves into forward moves, would that, could we transform like backward movements into forward movements, and then instead of having a double linked list, have a single linked list? That would be pretty nice, I think. That would be pretty nice. It would simplify, at least it would simplify the code quite a bit, I think. Let's try it. Let's say instead of links, let's say that this might be, by the way, the numbers. We're also accessing numbers here, which is a sort of big array, which we could transform into, but I don't know if we can transform this into 16 bytes. No, we cannot, because this number is, sorry, 16-bit numbers, because this number is way bigger than that. In fact, it might be bigger than 32 big numbers, if, I don't know, really. Can we do 2 to the 32? This is, well, no, yeah, it is 4 billion. And we have a number here that is, well, almost 1 billion. So when you multiply this number by these guys, but we can probably, since we are modding this, we can probably do some mod tricks on this and work with smaller numbers. But yeah, that would be an optimization to make this thing smaller, which could be fine, I guess. But what did I actually want? Yeah, I was thinking of just having a singly linked list. So we can say something like nexts. Yeah, next. So this is just going to be something like this. And we are just going to do this, I think. Next ID. So if it's this, yeah, I don't know if we even need to be U16. We could probably try to keep it as U size, but I mean, we also know that this should fit, so here to advance, which we just need to do nexts in this ID 2, yeah, and to move backwards, can say something like if number is negative, let's say that number, oh no, we have to mod it also, so num mod. Okay, let's think of the negative case as we were doing before here. Move backwards, we have this num mod, but okay, how do we think of moving backwards? Let's go to here. When we move the -3, which is here, it is starting between 1 and 2. So it moves here, 1, 2, 3, ends up between the -2 and 0. Yeah. And that would be the same as moving forwards 1, 2, 3 also. Why is that? How do we think about that? Is it the same as doing 7 minus 3 minus 1, like the length plus n minus 1? Does that make sense? I don't know. The -2, let's check this. So here -2 is here, so it moves 1 and 2 and it ends up here. So it's the same as doing 1, 2, 3, 4. So yeah, again, it's 7 minus 2 minus 1. Okay. And I guess we have these. We can actually do num which is u64 we can use the actual reminder, I think. Here it is what I want. Is it what I want? The actual mod that comes with Rust. We can say this as I64. This can be negative. This will be negative now. And we can say, okay, you need to move backwards. If it needs to move backwards, well, 0, that would be, no, that doesn't make sense because, well, maybe it does. If it is a multiple, yeah, maybe it sometimes does. You have to move backwards these amount of times, or forwards length it's not mod, it's rem. -1. Yeah, kind of. This should be sorry, I'm getting confused. As I64, I guess. Yeah, whatever. And here we're going to do this amount going forwards. So, no, just this. Instead of links, let's call it nexts. Okay. Okay, I'm doing two changes at once. I'm changing the double linked list to a single linked list, and also this removal of backwards movements. So let's say if this was a multiple, when we convert it to this super big number, or I guess even here, do we have like minus 5,000? We don't, but do we have minus 10,000? We do. Wow, that's a big number, but not minus 15,000. But yeah, we do have this, which should leave the thing. Oh no, it's not that number. It's, do we have this number? No, and this times 2 is 9,998. But we don't have this number, so I think we might not need to worry about them. So let's not worry about them. Okay, but now that we have a single linked list, does that mean that we only need to update 3 things? Maybe it does. So here, I'm gonna say, okay, let next be this. We don't need to update any previous. So next, the next, no, here we are updating the previous. That's not what I want. Actually, the next of what we have. Oh, but if we don't know what is the previous, we sort of need this doubly linked thing, right? Yeah, otherwise we're gonna screw it up. That's not cute. Oh, that's not nice. I think we actually do need the doubly linked list. Darn it. Because otherwise we don't know which is the previous of what we are doing, and we have to update that pointer, like the next of that guy. So no, this cannot be singly linked list, I think. One. Yeah, bummer. Well, let's discard this change. Quack, quack. Okay, I think I'm getting a bit tired, and I'm doing stupid things now. If we run this in release mode, do we still have? Yeah, we have a final runtime of 600 and something milliseconds, which is not great, but it's also not that bad, all things considered. It's actually half of what we had with the vector solution, so maybe I am okay with that. There's probably other things that we could do here. This ID2 is a pretty ugly name, so maybe we can change this to say how can this be named? This is, well, this is another ID, so ID2 is not so bad. ID after? So after this is what we want to put our current ID. And let's add a comment for this, +1 shenanigans. Move +1 so that we end up one more backwards so that we end up in the ID after which we need to insert ID. Okay. This is like we are moving this from the current position to this next position, but it's not like, yeah, destination ID could be. Yeah, could be that, I guess. Okay, these were all renames, right? It shouldn't affect the runtime. Yeah. As I said, there's probably more things that we can do. Let's take a final look to see if there is any egregious, horrible things that we can improve. We have these big numbers. These numbers. I guess we could make these transformations, because this is the numbers that we are, but afterwards we need to actually add up these numbers. But the transformation to these numbers, like mods, could be done before, and that thing could actually fit, like be could actually be a vector of U16, for example. Actually, I'm tempted to change U16 to an alias like ID. So let's do that. Type alias, let's say this is ID. Yeah. Well, ID. Here, I guess I'm not going to like this. U16. Use a small integer for number IDs, so that they take at the arrays fit better in processor cache, or so that the vectors are more cache friendly. Okay. Beautiful. So yeah, I guess this following up of things is a bit complicated. We can probably improve things by doing that optimization that I mentioned of checking to see if the number is less or more than half of the length. That won't improve things too much, I think. Like at the very most, it would make the runtime half, but not more than that. It's not like an algorithmic improvement. And I am wondering, is there some trick here, something that we could do to, instead of doing this computing, like this advancing on the linked list, computing the final position directly, that was something that we could do with race, but then we have to shift things and update everything else. So yeah, I think this is kind of a trade-off. I don't know if I can improve this. So I think I'm going to leave this in this shape for now. Maybe tomorrow with fresher eyes I can see something better. But for now, that's it for today. And if you have been, thanks for watching and see you later. Bye bye.